in looking at this is conventionally when I do these questions, I set two variables. I let an x represent this and a y represent this. But you can actually do it with just one variable as well. Okay. So Mr. Poling here has, so write an introductory sentence, write the equation, simplify, solve, concluding sentence. And I have a feeling IB is kind of big on like just the formality of like therefore statements, things of that nature. Let statements is a big one, right? So here's what I'm going to say. You could say, okay, here's the first question. Let the sum of two numbers be 42. Okay, one number is 8 less than the other. Okay, what are the numbers? That's what you got to figure out. Okay. So, how about this? We'll say let x represent, you can use like abbreviations and stuff here if you want. REP with a period is represent, just so I don't have to keep writing it all the time. Let x represent one number, you could say. Right? And then you could also have like, by default then, x minus 8 is the other number. Okay, again, this is a little bit, having one variable is strange for me. Well, I haven't done that in a while, or if ever. Okay, normally I'll just say let x represent one number and y represent the other, and I have a method to solve it, and that's a grade 10 method. But there is a grade 9 method as well. Okay, so we know, here are your two conditions, right? X represents one of the numbers, and x minus 8 is the other number, okay? And it says the word sum means what? Vincent? Yeah, so I'm going to like, when you say the word total, I'm going to like add it up, right? And so these two conditions here, I'm going to add these two conditions together. And what's the word is mean in mathematics? Do we know? There's always, I don't know. I like doing this sometimes, like with the word problems in particular. Sometimes this is my like approach to word problems. Sometimes you start scratching out words and putting what they are in mathematical symbols. So what's the mathematical symbol for is, Sarah? Equals. Okay, so here's how I would do this. Okay, you've got two pieces here in the boxes. I would say, okay, when I add these two conditions or these two numbers together, right, we're going to find out what the two numbers are. And they're equal to 42 when I do that, right? So I know x plus x minus 8, those are your two conditions. That has to equal 42. Okay, so you can directly see why I'm asking you to do what I'm doing on the formatives, because you need to know how to do that in order to solve these word problems. So remember what we just finished doing on that quiz, organize, right? Give me the variables on the left and numbers on the right, and you're done. That's it. There's a little bit of thinking past that, but for the most part, all the hard stuff's done, right? So, what is an x plus an x? What's 1x plus 1x? 1, yes, Elizabeth? That's 2x. 2x minus 8 is equal to 42. Right? So you say, okay, I still don't have the numbers on the right, so do that. Add 8, add 8. So 2x is going to equal 50. Are we all right? So you can divide both sides by 2 to get x by itself. So x equals 25. All right. Now what? Did I answer the whole question? How many numbers do I need in this question? What does this question ask me for? Declan says 2. Does everybody agree? There's 2 numbers here. I've only got one of them. But I have a condition that I wrote at the very beginning. We know from this little chunk of the question, one number is 8 less than the other. Well, we just found one, the bigger one, right? And so if I go back to find the other number, it's going to be 25, because that's what x is. Take away 8. That's going to be the other number. Everybody agree? So 25 minus 8 should be 17, correct? So then you can write a little therefore statement. You say, okay, the larger number oh boy. Smaller number is 17. Okay, I think the hardest part is coming up with the equations. As per usual. That's not going to go away. I think that's probably the hardest thing you're going to have to do all the time. Is like come up with the equation and then apply the skill that you've drilled and killed. Okay, it's kind of the application side of things, right? All right. Now the next one requires you to know a little piece of information. I wonder if you guys know what it is. Sides of a triangle are 3 consecutive whole numbers in centimeters, okay? The perimeter of the triangle is 48 centimeters. How long is each side? Yes, Declan?
15 centimeters.
Okay, I don't know if it's 15 yet or not.
Well, x is 15.
Oh, okay.
Not each side, because they're different.
Okay. So we have what x is proposed to be, so let's figure out if we know what it is, okay? So again, they're going to be very strict in you showing. Look, I was talking to one of the kids in the grade 12 IB, and he was losing marks all over the place for not solving questions in the form that they're looking for. Right? So, anyway, we know the perimeter of a triangle is going to be like side 1 plus side 2 plus side 3. Would everybody agree? Okay, this would be like, I'm just trying to take as systematic of approach as I can, right? Okay, so that's the perimeter of a triangle. And so it told us what the perimeter is. It's 48, right? So 48 is going to equal, okay, well, what's side 1? It doesn't matter which one you call it. You call this side 1, side 2, side 3. Right? You're going to say, okay, side 1 is x plus 2 plus x plus x plus 1. I'll put these in brackets so you can see them better, actually. I think anytime you guys make a substitution for anything, you put some stuff in brackets. Okay? Now, no different. You can get rid of the brackets. There's nothing fancy going on, so there's no, like, you don't need to expand anything in, so nothing's going to happen if you just magically got rid of the brackets. So now you can do what? Collect the like terms, right? So I see x plus x plus x, that's 3 x's. And then I also see what? 2 and 3. So 3x plus 3. Are we okay with that? All right, all I'm doing is collecting like terms. Let's solve for x. Once you have x, then you can solve, like, you can put x into the picture and solve for each of the side lengths. Okay? So, it appears Declan might have been right. So 48, to get the numbers on the left, you take 3 away from both sides. So it's 48 minus 3 is equal to 3x. So 45 is equal to 3x. And to get x by itself, divide by 3, divide by 3. X is equal to 15. Okay, good. All right, now to solve for each of the sides, right? Side 1 is going to equal 15 plus 2 is 17. Side 2 is going to equal 15 because it's just x. And side 3 will be 15 plus 1, 16. Okay, so there you go.